Our notes today are going to be on classifying polynomials and using polynomial vocabulary appropriately. The first thing we're going to learn is how to write a polynomial in standard form. We will then classify by degree and number of terms, and we will also know what the coefficients are of each term. So let's first talk about terms. The terms of a polynomial are the expressions that are separated by plus and minus signs. So this polynomial has 1, 2, 3, 4, 5 terms. The degree of a polynomial tells us the highest exponent. So in this case, our highest exponent is 4. We would say this is a 4th degree polynomial. To write a polynomial in standard form, we have to make sure that the powers are going down in order. So highest power all the way to the left, lowest power, meaning no x's, all the way to the right. And a coefficient, just a reminder that a coefficient is the number that comes before a variable in an expression. So we would say that the coefficient of x squared is -8. The coefficient of x cubed is 5. Let's look at a couple of examples of how we would classify a polynomial that is already in standard form. Notice that these are in standard form because the x comes first and no x in the second term. So this polynomial has 2 terms, so we would say it is a 2-term polynomial, and the highest degree is 1, since there is just one x there. So we would say that it is a 1st degree. Sometimes a 2-term polynomial is called a binomial, and if it's 1st degree, we call it linear. In our next example, we have 1, 2, 3 terms. Sometimes that's called a trinomial. And the highest degree is a 2, so we would say that that is a 2nd degree polynomial, and sometimes we call that a quadratic polynomial. And in our last example here, we have just 1 term, so that's a 1-term polynomial, and the highest degree is 3, so we call that a 3rd degree polynomial, and sometimes we call that a cubic polynomial. Let's look at some examples where first we have to write the polynomial again in standard form. Before we do that, we need a quick review of exponent rules. So just as a reminder, when we add x and x together, that gives us 2x. But when we multiply x by x, that's like finding the area of a square, x times x. And we say that this is x squared, represented by the area of x times x. And we'll go on to look at an area model later. So again, when we add x and x, we get 2x. When we multiply x by x, we get x squared. Also a reminder of a skill that we've been practicing, which is combining like terms. Like terms have the same letter with the same degree. So here we have the variable x has the same degree on it. Those are both 1st degree terms. And this one is different. This has a squared on it. That's a quadratic term. So we can combine these 2 terms to get 3x, but the x squared cannot be combined with 3x, so that one we would leave alone. Similarly, in this next example, we have x squared and x squared. That means these are like terms. So together, that's 5x squared. We cannot combine the x because that does not have a power on it, or it has the power of 1, not the same as the other terms. So now that we remember our exponent rules and our combining like terms rules, let's see if we can rewrite some of these polynomials and then classify them. So let's take a look. In our first example, we have an x squared, but we have to multiply this next piece by 3. So just a reminder of the distributive property, which we'll practice again in a couple days, I'm going to multiply each of those terms by 3. So I have x squared plus 3 plus 3x squared plus 15x. To write this in standard form, I need to get all the x squareds at the front. So x squared plus 3x squared gives me 4x squared. Then I have a 15x would come next. And finally a 3, since that has no x's on it. So my standard form would be 4x squared plus 15x plus 3. To find the degree, we would look for the highest exponent. And to find the number of terms, we count the expressions that are separated by pluses and minuses. In our last example, we are going to combine our x cubed terms. That will give us negative 4x cubed. We have a single x term, and then we have a positive 2, so we're going to write plus 2. So our standard form is negative 4x cubed plus x plus 2. Notice that we go down in order of degree. The highest degree is 3. This is a cubic function. So we would say that this is a third degree function, or excuse me, a third degree polynomial. And the number of terms is separated by pluses and minuses. So we have 3 terms in this polynomial. So now that we've done some examples, you should know how to write a polynomial in standard form. Remember, that means that the exponents go from biggest to smallest. You should be able to classify by degree, meaning the highest exponent, and you should be able to determine what kind of polynomial it is based on the number of terms.